also want to say a huge thank you for everybody who has been participating. It was a lot of effort from a lot of people around the world, both team behind the TIMETOACT Austria, our marketing, Nina, Felix, Agiz, also our friends and partners at IBM, and who were helping us with to run the Watson track, and also everybody who spent their time and nights and days. Some people even took their vacation to participate in that challenge. And afterwards, we will be continuously sharing all the results, all the data, all the individual submissions. So we're hoping to be able to push state of the art together. Before we move forward, just a few notes. So first of all, the results they are scored against the ground truth data. This ground truth data was not generated by LLM, so we're not using LLM as a judge because it has so many pitfalls. So I've been, with the help of tools, with the help of colleagues, been going through this hundreds of PDFs and pages for, as you all know, one of the reports had 1,043 pages, I think, and manually checking hundreds of answers. It thinks the job was much easier for me than for the participants because I had already a cloud of existing submissions. So I could already pre-see, for example, all of the pages that were relevant, and this made searching in the to verify the ground truth data much easier and faster for me. But it still took quite a few days. The point that I'm trying to say is that the ground truth data, it might have some flaws. I may have missed 1 or 2 pages on the PDFs. I might have mistyped an answer, but for the majority of the answers, everything should be correct. And I believe if there are any typos, we will fix them, but they shouldn't affect the global score. So basically, the ground truth data is best effort, and it is not biased towards any participant. Second thing, we had more than 350 registrations, and we had tons of submissions. For today's session, we'll be focusing only on the nominations, because every team had a chance to nominate only one submission for the leaderboard. Why is that so? Because we didn't want teams to try brute forcing the best solution. For example, if a team could just send, for example, 100 different submissions, technically the best submission could win. So that's why during the submission period, each team had to nominate existing one of the solutions that they thought the best. An actual disclosure, the best solution wasn't the nominated one, but still. So we, for now, we're talking only about this submissions from the teams that were nominated, and only the submissions that were sent during the February, before the March, because like that was in the rules, we're giving only 3 days to generate the answers. Also, one small thing is that we will have, so we were ranking on the quality of the answers, but we were also giving a little bit of the bonus scores, because this was not only the retrieval augmented generation, but it was like the retrieval is the most important part. And this is one of the insights that we got during a review of the results, and we'll share that insights later. So as you recall, in the response schema, we had the answer, and we also had asked you to provide the references that prove that results are correct. Because if for somehow your system gave an answer, but it wasn't able to find any relevance at the page, it could be a hallucination. So, essentially what we're doing is that if your answer is correct, then you get 1 point for the question. But then also, you could get a few extra fractions of the point if your page that you found was actually one of the pages that was containing the results. And when you hear, when you see in the leaderboards words like R score or G score, so R is the quality of retrieval. G score is the actual quality of the final generation. It's a final answer. And most of the score gets from the like G score, but retrieval quality can give some bonuses. Having that said, let's go to the prizes. So first of all, let's start with the IBM watsonx track. So IBM watsonx, they provided us with access to their models that they're hosted on watsonx, and access to these models was either through the watsonx interface or through the proxy interface that we deployed at TIMETOACT to make it easier to access the models. And let's see what teams were able to do that with these models. So the third place goes to the Nightworker team. Nightworker baseline was their submission, and the hash is 3560E. So every time, like on every submission, I'll be referring to the hashes, which are actually the signature of the submission. So that later anybody can verify that it was exactly the same submission that got the score. So they got the score 96.7. And I think the absolute maximum score was 130. So 33 or 100 coming from the answer score, maximum possible correct answer, and 33 coming from the retrieval quality. So this team used a DeepSeek R1 Distill Llama 70B, which is one of the latest models that came from the. So actually, no, it's a distillate. So these are insights taken from the DeepSeek R1 model, which is reasoning, but they were trained upon the Distill Llama model 70B, essentially teaching it how to reason better. And actually, in our own reasoning benchmarks for the business workloads, Distill Llama 70B, given the structured outputs, it can work almost as good as DeepSeek R1, even beating, for example, ChatGPT 4o. And as you know, we were asking not only to submit the answers, but also fill AI insight questionnaires. It had a couple of online questions, but answers to them are really important to helping us understand what is that makes the best solutions work. So the third place with the IBM Watson track, it was a DeepSeek R1 Distill Llama model that was also using vector database with all mini LM L6v2 using IBM Granite embeddings, and obviously then querying to get the most relevant page in the document, and then using DeepSeek R1 Distill Llama 70B to get an answer. They get the third place. Second place, Raskazov Kolesnikov, multi-agent IBM OpenAI. So this is a mixed system, and that is allowed. So they were using Llama 3 400B instruct, Granite embeddings, what else is hidden, text embeddings, and GPT-4o mini. So as you can see here, they were generating RAG model database, extracting key metrics. So essentially, this is a data extraction pattern. And then using the extracted key metric to find the most similar question in the database. Then they used the answer from the most similar question as the answer to the question, and used LLM, which is GPT-4o mini, to generate the answers. They get the second place. The third place, it's pure IBM. So this is Ilya Rys. He gets the first place, and he was using Llama 3.3 70B instruct from IBM watsonx. And this setup is very interesting because if you're using a model from IBM, and IBM models are locally capable, which means that they might be slightly less or noticeably less powerful than, for example, GPT 4.5. But they can also run within your security perimeter, and you will completely own them. And in order to get good results with a model like that, you need to take extra steps. And you will actually see that a bit later. But so in order to get the score 120.3 with this model on the IBM watsonx stack, so Ilya was using PDF parsing with a heavily modified Dockling library. And actually, Dockling library is, based on the analysis of the form submissions, is one of the most frequently used PDF parsing libraries these days. And one of the advantages of the Dockling library is that it extracts not only the text, but it allows you to extract text within the context, which is actually very valuable. And it can affect the retrieval quality a lot. He was using dense retrieval, which I recall is related to using FAIS database for the search. He was using router pattern. Router pattern is a common pattern that is equivalent, for example, to the triage, where you essentially use a request to LLM to help you classify the type of the task and then decide on which workflow in the response handling path you will take. This is similar, for example, to first-tier customer support calls when you call to some company, and before directing you to a specific specialist, they ask you a couple of questions, and then they direct you to a proper specialist. Or this is similar to triage in the hospitals, where you come first to registration desk, and they decide like, are you very sick, or is your leg hurting, or are you still breathing? And then depending on the outcome, they'll direct you to the proper specialist. Then he also used the pattern, or not pattern, pattern document retrieval, because based on the embedding, you can get a chunk of the text, but this chunk of the text is not enough for the context. And Ilya would retrieve actually the entire PDF page. Then it would go into the LLM again to rank and prioritize the best, most relevant pages. And then he also used SOCOT, like this is a common pattern that it means structured outputs chain of thought. And actually that is a very interesting thing. So structured output is a thing that you can see, for example, on OpenAI. They were the first one to introduce that. Then it showed up on Google, then it showed up on Mistral and on Fireworks. A structured output is essentially a way where you tell the LLM provider, hey, I want the response to be in this specific schema, because I want to load it back to the object and I don't want to bother with parsing. And this thing, first of all, helps a lot to reduce the complexity of the code, because you'll no longer need to do the regex matching. You don't no longer need to do the string matching. You just get the response from the LLM and load it into your object immediately. That makes things easier. And this is usually implemented by the LLM inference engine that provides constrained decoding. It simply allows a large language model to pick on the tokens that will match the schema, and that will be correct. And this is important not only because it helps to simplify logic, but it also because it helps to encode chain of thought routine directly in a single prompt. This is something that we've learned after running the first round of the Enterprise RAG Challenge last year. Because if you take a structured output, you can force large language model first, for example, to look at the data, then maybe summarize it with its own words, and then afterwards come up with a specific answer. And in our communities, we're calling it a checklist pattern usually, or custom chain of thought routine. And the simple thing of using custom chain of thought routine, it allows to do a lot more cognitively challenging tasks in a single prompt. And it is so useful that basically we're using that TIMETOACT group, for example, for pretty much all of the new AI projects. And in my AI research, when I'm seeing teams, they get most of the immediate benefits from the AI by using the structured outputs with custom chain of thought routine. For example, I think a couple of weeks ago, a team just pinged me on the Telegram asking, hey, Rinat, we have a problem. We want to, we have challenges extracting data in our AI system for the tickets from the text messages. And like it hallucinates like crazy. We don't know how can we improve the quality. And my suggestion was just read on the structured outputs, read on the chain of thought routines, and just look what people are doing in the community and around the world to guide the model thinking for the prompts. And then sometime later, they came back to me and told me, hey, like this is perfect. It's so simple. It is so obvious. And it allowed us to increase the accuracy of extraction of structured data extraction from the chat messages into the tickets like massively. And this is actually not new. This is something that we've learned as an Enterprise RAG Challenge community last year from the first round of Enterprise RAG Challenge. And we have links to that GitHub repository. We have links to all the answers. But the fun insight about this submission is that in the current deployment for for the IBM watsonx, we didn't have, unfortunately, time to provide structured output functionality for the IBM Watson. If we do another round, we'll definitely do that for the reasoning models, for example. So the structured output, the constrained inference, was not available for the model of Llama 3.370B instruct that Ilya used. But, and in order to counteract that, he had to use a structured output reparser, or another name for that is schema repair. Essentially, when you ask a model to give you answer in some schema, it will do its best to give the answer in some schema, but maybe it will fail, and Pydantic will then complain. And what Ilya has done, he just asked the LLM if the schema validation fails, hey, Llama 3.3, that was the schema, that was the answer, please repair the JSON so that it is parsable. So that is called schema repair. It is in Wild, is, for example, provided for you by the library. I forgot the name of the library. I think it was Instructor. But then the funny thing arises, and it highlights the capabilities of the models. So this implementation of Llama 3.370B instruct, it didn't have actually real structured output. It didn't have any constraint decoding. And yet the custom chain of thought with the structured output worked. Why is it that? The whole point here is that we don't need to be able to force the 100% the model to follow some chain of thought, custom chain of thought, and reasoning within the prompt in order to be able to benefit from the reasoning. By simply asking nicely the Llama, hey, could you please fill the JSON in this order? Like first fill the preliminary fields, then write the summary, then actually summarize it into a concrete answer. Even if the model doesn't have the constraint decoding, it will try its best to lay out the answer in such a way. And because we essentially are optimizing how large language model will write its output results, we're optimizing the layout of this output result. And because the latest tokens, for example, are always the hottest in the attention, and we're actually breaking the task into smaller tasks which lead to the major answer, it is still enough, even without the structured outputs, to increase the quality of the answer of the model. And with the latest reasoning models, as we'll probably see in the next iterations of the Enterprise RAG Challenge, it even helps better. Okay, and then to wrap up with this IBM winner, the final logic goes for the majority vote self-consistency. And that combination of different patterns helped to get the highest score. And as you can see, it is not that different from a generic RAG architecture that you would see generally. It is still RAG with maybe vectors, with re-ranking, but it just has a few twists that allows it to use local models, and that allows it to get high scores. So congratulations for the winners of IBM track. Let's go to the primary prize leaderboard. There were more submissions here. The second place, why the second place? Because we had two winners competing for the first place. So we have one second place and two first places. So the second place is taken by the Hopeless team with a submission called Slow Run and Bugs. That's the hash code of the submission. The score is 117, so which is closer to the theoretical score, max theoretical score of 130. And the author was using GPT-4o model, one of the latest models from the OpenAI, or not so latest, but it still has one of the best return on investment ratios. And he was using dynamic structured outputs. So once again, we're seeing the pattern that people are using structured outputs, which may be varying depending on the question, but they still help to extract the data, they simplify parsing, and they help to get more results from the models. He was also using ontologies. And ontology is a nice term that we're seeing more and more used in the communities in practice. It is essentially, when applied to the LLM, it's a hybrid. For example, you can take a list of 100 categories, and then you can convert these 100 categories to a literal in Pydantic. And then you will essentially have 100 tags. And then you can tell OpenAI, hey, please classify this chunk of data and using one of these tags. But because we're using structured outputs, the large language model will be forced to pick only one of the predefined tags. So it will not be just keywords, it will be just predefined tags. This is similar to the research process as if you were reading through the book and putting predefined labels or indexing pages to terms of content. And so ontologies, this is something that became really popular in practice in the projects, which are knowledge intensive. And ontologies really shine when you have a properly implemented structured output. The schema repair would not help much here. And then also there is another pattern, what is called query expansion. That is also another pattern from my communities. Essentially, it is a form of text to something conversion. Like, for example, when you get a human request and you need to search for some data inside a large corpus of text. And you don't want to use embeddings. And as you actually can see here, embeddings are not used at all. The problem with embeddings that they're black box models, and you cannot improve the quality of a system using embeddings in a predictable way unless you start adding more complexity. And so this solution works around the embeddings, but it still does semantic search by using query expansion. And query expansion, you take a certain text that you're trying to find and information for that, and then you ask a large language model, hey, given this request, and given these indicators, given these ontologies, please, or maybe given even this full text search engine, convert this query into the search query that will be able to successfully find information in my database that is indexed this way. And then basically, as you can see, he was using majority selection to stabilize answers and to essentially this is using ensemble of answers, and then chunking by pages with focus on balancing pages versus tokens. So that got him score 117 and second place. One of the first places is taken by Emil with LLM search with score 121.6. And as you can see, he was using multiple OpenAI models for O-Mini, for O, and O3 Mini. And here's another recurring pattern that we've seen in the practice already, but this is not the mainstream. There is no embeddings. There are no vector search to be used here. Because these days with the LLMs, and if you want to have precise answers, if you want to have less hallucinations, if you want to have correct signal versus noise ratio on the generation part of the LLMs, you don't use embeddings. They're good for the prototypes, but for the precision, they're not so good. So here we still see the same pattern. Query expansion is used to convert incoming query into the semantic space of the documents. We're searching relevant pages using fast and cheap LLM, which is a nice take. I think then he was using GPT-4 O-Mini for the search, then question answering and answer finalization. So essentially, it looked like this solution was even brute forcing the answer. And the second first place was taken by Ilyaris. He is using essentially the same approach as he used for the IBM model. So it's still PDF parsing with heavily modified document library, pretty much the same architecture, and just using O3 Mini for the driving the pipeline, and obviously not using structured output repair or schema repair because like OpenAI models support structured output out of the box. So congratulations for the wins. Thank you for helping us to push state of the art and like prove or demonstrate which results are working in practice in challenges like that. So to summarize, this is the nomination only. So as I remember, only a team was allowed to nominate only one question for each of the only one submission for each of the leaderboards. So we have 4 final nominations for the IBM watsonx track for this course. We have a lot more nominations for the main prize track because it was more common ground. But actually, as you can see, with IBM watsonx, the top score was 120. For the prize leaderboard, the top score was 121. So this actually leads us to a point that a good architecture, if it's properly designed and if it's like well thought through, if it's using structured outputs and sometimes ontologies, custom chain of thought, it will reach the top scores regardless of the underlying LLM models, large language models. And this is because for the business workloads, the top open source models that we already have available to us, especially Llama 3.3 70B or the R1 distillate of 70B, they're already good enough. And on our benchmarks, which is the latest reasoning benchmarks, these models beat 4.0 GPT, which is very good for the majority of the tasks. Smarter models are sometimes overkill. And also we have a separate score, once again, 1 nomination from each team that were using local only models, and these are the scores. Obviously, we have a lot more data. And I think this is, I even remember, this is the total leaderboard, which is still 1 submission from each team at most, without any constraints. And this is the official leaderboard, the public leaderboard that will also be published. And we'll share all the links. But actually, this is not all, because the data that I've been showing, this was for scoring. And we had a lot more forms submitted, and we had a lot more experiments. So like, even though we're done with our Enterprise Rack Challenge, we'll continue using the information of that to push state of the art, and we'll continue sharing the additional results. Because one of the best leaderboards that I have right now, it's an experiment leaderboard, where teams were, as you remember, allowed to send any number of submissions up to right now. Actually, you can still send a submission until the Monday, because early next week, I'm going to shut down the submission API. And first of all, I recommend you doing that, even if you're not aiming for the score, just to finish that. Because so many teams from the first round and already teams from the second round were telling me that the most value they get simply by going from the beginning of the challenge to the end of the challenge in a very concrete, controlled experiment. Because things that you're learning by doing this challenge, they are applicable to practical projects. People are getting hired because of the leaderboard positions of the Enterprise Rack Challenge. And even just one thing that if you went for this challenge from the beginning to the end, you've learned the hard way that sometimes PDFs will have 1,000 pages. You'll learn the hard way that sometimes PDFs will be copy protected, or sometimes that PDFs will be read-only. And this is a practical experience that will save you or your future employees or your future co-founders a lot of time while building real-world Enterprise Rack Challenge. So first of all, the submission API will still be running until early next week. And early next week, I will shut it down because I will also publish the ground truth answers, the same ground truth answers, which we use to rank this course here. A reminder, they're not perfect, but we've done all we could, and we've invested a lot of time to make sure that they're as correct as possible. Also, of course, we're going to be writing blog posts about the best articles. And some of the people have already started collecting blog posts about their experiences of participating in the Enterprise Rack Challenge. And we will be asking kindly, but persistently, winners of each of the tracks to write a blog post. So either they'll publish the blog post somewhere else, and we'll link that on the TIMETOACT blog, and we'll copy everything to the Discord, of course, or they will even publish as a guest writers on the TIMETOACT blog post. Then we also have the multi-submission leaderboard or the experiment leaderboard. In that leaderboard, like, there are no constraints, and team was able to submit multiple submissions, and there are actually submissions that are pushing state-of-the-art closer to the theoretical maximum score of absolute perfection. I think the highest score was 126. I don't know. I haven't double checked why the author of this submission didn't nominate it to the prize. Maybe he wasn't certain. But like there are lots of interesting insights there, and we'll share this multi-submission leaderboard, essentially the experiment leaderboard, afterwards as well. And we'll be publishing reports, which also show us some of the insights that we've learned from this round of the Enterprise Rank Challenge. For example, first of all, one of the most interesting insights was about the quality of the retrieval versus quality of generation. So in this leaderboard, in this competition, we said that we're going to judge you not only on the quality of answers, but also on the quality of the proof of the documents that you pulled. Because when you build an enterprise system for the business, for example, you've built a system that is correct 80% of the cases. And by simply giving your customers a system that is correct 80% of the cases, it will probably be useless. Because if a business exec knows that when he's asking some system to fetch him a report, and 1 out of 5 questions is going to be answered incorrectly, people are not going to trust the system because they're going to spend more time correcting or looking up for the errors. And because systems are always ranked on the quality of the answer and how much time they're going to save, this system is not going to have a large positive impact, meaning that, okay, we're going to deploy an assistant to the experts that maybe review the invoices, but this system is going to be correct only 4 times out of 5, and once it's going to be incorrect, but you don't know when. And the experts will not trust the system, their assistant, and they'll have to do double checking. And it means that they're spending more time per invoice, and there will be less efficient, and simply deploying the system will cost the business twice. First, for the cost of development of system and integration, and then the cost of the ongoing time waste. And how can we improve that? We can reframe the thing that we're not building you an assistant that gives you the answer, that we're building you an assistant that will do the research for you, that will do like the data digging. And when it provides, for example, you the answer about a question from the business database or from the Confluence websites on the company, first of all, it will look up the relevant pages, and then it will summarize the answer. And we will show you this every time. This is similar to how OpenAI is doing research. This is similar to how Perplexity is doing research. And when when the system is actually deployed, it will be fine for the experts if one of the 5 answers is incorrect. Because first of all, they can quickly scan through the pages, because they remember the pages, they just couldn't bother to find them. Like, hey, did the system pull the correct answers? Did the system pull the correct documents? Did it look in the right places? And then, yeah, it looks like it pulled the correct documents, then probably the answer is correct. Or no, it didn't pull the correct documents, or it missed some documents, but at least it pulled some of the documents correctly. It already saved me the time. And I'll just keep up the research from the place where the system turned the wrong way. And this is how business likes the systems to be deployed, especially which work with the knowledge. And by providing this proof of evidence, first of all, we help to build trust, we help to save time. And also, this is why we in the Enterprise Rank Challenge asked to provide references that prove that the system saw the correct pages, that it was able to find the correct pages. Now, the interesting insight is that in the leaderboards, you'll see retrieval score, R score, and a generation score, G score. And when scoring the quality of the submission, quality of the found pages, I use the same metric that I'm using to measure my own systems or measure systems in the reasoning benchmark. This is similar to, it was initially based on the math Olympiad called Kangaroo. Essentially, you get, for example, 1 point initially, but for every required page that was missed, you're losing 0.25 of the score. So basically, if you missed 4 required pages, then the score is 0. And if the system actually pulled irrelevant page into the context, then the score is penalized by 0.1. Like this is an internal score. I've been using that just to judge my own systems. But the interesting insight is that we got is that on the leaderboard, let's actually switch to the leaderboard here. It feels as if this retrieval score sets the theoretical limit of the accuracy of the system. So overall accuracy of the system is generation score. It's how correct was the answer. And actually, if you look at that, the generation score is almost never higher than the retrieval score, which kind of makes sense in the hindsight. Because if you weren't able to find a good pages, or if you had too much junk or noise on the input, then the large language model on the last part, no matter how smart it is, will not be able to synthesize the correct answer. And this actually, so first of all, one hindsight is that this simple score seems to approximate not that badly. It's not perfect, and the rule doesn't always hold true, but still, the quality of the generation will depend on the quality of the retrieval. And that's why, for example, in the classical RAGs that use a hybrid database with embedding search, you either will get a lot of hallucinations in the end because the retrieval on the vectors is not so good or easy to manage, or you will need to implement a lot of logic just to filter out the embeddings and find missed fragments. And the second thing, essentially, if you're looking, for example, at the top place with LEREs, it looks like his generation score is very close to the theoretical limit of the quality. But some of the other systems, that there is a gap between retrieval score and generation score. And probably it's like, and we know that if a system retrieves, finds the pages correctly, then it can answer correctly. So there is maybe a small gap that can be bridged and that can be changed in the overall architecture of the system, just to bring the generation score closer to the best possible score that the current enterprise RAG system can achieve without even changing this retrieval system. So that is one of the insights. And in the community, we have been already talking about the signal versus noise, and that there are three ways that you can make sure that the large language model answers correctly on a given task. First of all, you need to make sure that it gets enough correct information. Second, you need to make sure that it doesn't get a lot of other noise that is not relevant. And third, you need to make sure that the task is not cognitively complex for this specific model. And if it's cognitively complex, you either implement a custom chain of thought routine with the structured outputs to drive the model through the custom checklist and make the task easier, or you even split the task into multiple subtasks. But like, it is good to know that from the experience and from the theory, but in practice, like when you see that the numbers kind of prove that insights, it makes you more confident, and it allows to push the state of the art even further. So long story short, thanks a lot for the participation. Thanks a lot for the enthusiasm. Thanks a lot, especially for the people that were going through the problems, facing the problems, solving the problems, and then sharing the solutions or even retrieve data in the Discord channel and collaborating. Because the whole point of this challenge is to go through the challenge together, to learn together, and to push state of the art together, and to maybe use these learnings in the next Enterprise RAG challenge. Okay, now, thanks again. Once again, this challenge is almost done. You can still submit your questions up to early next week. If you have time, please do, because it will help you personally a lot. But like, we haven't shared all of the insights because it will take some time to go through the information. It will take some time to go through the synthesize the answers, insights, numbers, and we'll be doing that in the upcoming months, and we'll be sharing all of the insights on the Discord channel. And I think somebody raised a question. Or no? So if you have any questions, we can try typing them right now into the Discord channel. Or just raise your hand and speak out right now.
Hi, I have a question.
Yes, please.
When Leaderboard will be available publicly?
So basically, we'll need to work with our marketing. I'd say early next week. So I can copy paste the existing Leaderboard to the Discord channel right now, but officially it will be published a bit later.
Okay, thank you.
Basically, one thing that it might take time to be published on the TIMETOACT website, because we'll need to do a little bit of explaining, because we have so many leaderboards. So we have like the leaderboard for the prizes, where each team could submit only one, but we'll also have the experiment leaderboards where like all the submissions from different teams count. And we also have the local filter leaderboard, and we also have the IBM leaderboard, and we also have the prize leaderboard. And all of the leaderboards are available because we tell different sides of the story. But we'll need to figure out how to publish them correctly. But the raw dumps I'll be pushing to the Discord shortly today. Okay, Make, you have a question?
Hi. So in those leaderboards that you have shown, are there all submissions, or they are like top like 20 or something like that?
Okay, so the leaderboards that I've shown right now, this is the leaderboards that where we take only one one submission from each team. And also we're showing only the leaderboards where the team has not only sent the code, sent the answers, but has also filled in the questionnaire. So if you submitted the answer to the RAC, but if you haven't filled up the questionnaire, please do so, because then we'll be able to correlate like the correct insights to the submission. But also afterwards, like if you have any questions, so if you send the answers to the API, and if you filled in the questionnaire, but you still don't see your submission on the leaderboard, please, like on the largest leaderboard, please ping me and we'll find out why. Okay.
I have a question. Okay.
Yes, please.
So I've seen that there are like people who got the first places, and it would be interesting to see the Git repositories and the code that they have. Would it be possible to so that you could share some link if they post the code? Thank you.
Yes. So I'm actually gathering all possible insights, and I'm encouraging everybody, not just the people who got the top places, but everybody to share links to their blog posts, to share to their GitHub repositories. And you can do that either on Discord. There is in the Rec channel announcements, there is a separate thread that is called if you write a blog post about your participation in the RC challenge, please don't hesitate to link them. Or just send me a direct message on the Discord, or send me a direct message on the Telegram, and we'll add your links to the global link index, and we'll publish that, and so that anybody else who is interested in seeing the results will be able to look at them. Okay, do you have any more questions? I think there's something in the chat. Okay, and there is also clarification from the TIMETOACT. Thank you, Nina. So since we have 2 first places in the regular track, the top 2 places will each receive a 500 euro voucher. So no splitting here. And also so 2 things to continue. So first of all, we'll be publishing things in the Discord channel and on the blog of the TIMETOACT group. So you can stay tuned for any insights there and there. And also we're hoping to run more enterprise RAC challenges after we finish digesting the insights and sharing them with the community. And maybe the next RAC challenge will be focusing more on pushing forward what we've done, we discovered in this round. So more reasoning models, more structured output, maybe better APIs if you're working with the IBM, and more concrete challenges. And to answer the question about the cutoff date for the boards, so the prize boards, they had cutoff at the February, because we said that for the prizes, we will take only the responses done in the first a couple of days, because we don't want to encourage teams to start actually proofreading the results manually, because it has to be automated. The answers have to be automated. But for all the other leaderboards, which are not linked to the prizes, and we'll be publishing all these leaderboards, one of the cutoff dates is for the official leaderboards is last midnight. But I'll also be publishing the full leaderboard, which will include all answers from all teams, from all submissions, as long as they had filled in the questionnaire and you have time until the early next week. Okay, having that said, thanks a lot to everybody who has participated. Like you helped to learn a lot more about what is working and what is not working in practice, because this is a huge overview. This is actually a huge research that was done by lots of different teams that shows how completely different architectures that use completely different models that were built with completely different mentalities, different approaches, different patterns, maybe even different coding languages, that how they can compare in practice on a single challenge. And that was actually not that easy, because we had 100 PDFs, 100 questions. And thanks a lot for investing your time, patience, and pouring your soul into getting these results. And thanks a lot for trusting us to run this competition. We will process and we'll share all the results, all the data with you. And let's hope we can make future eggs more practical and more fun to make. Thanks a lot.